Hello guys, gals and NBs. Let's talk fluid sims. Particularly two-dimensional ones. I will not show you how to make one today, but I will show you how to use one. And in the process we will make a simple 2D particle system with just a few lines of GLSL. So the first thing you need to do is to get your hand on a 2D fluid sim. How will you do that? I'm going to give you a few options. You can make your own. There is an absolutely fantastic tutorial on YouTube by 3 Dashes. I've linked to it in the description. If you follow that to completion, you will get a deeper understanding of fluid mechanics. And I will show you how to use that to integrate it into our system. This project would not have been possible without that tutorial. The second option is to grab this TOX from the derivative forum that is based on the 3 Dashes fluid sim. I will also show you how to set that up. Maybe you have your own fluid sim or the fluid sim that Paquita 12 made. The same concepts will apply as long as it is a grid-based fluid sim. Or you can download this component from my Patreon, it's available there. There, you can also download a lot of project files that use this solver. If you have my component, skip to this time code where we set that up. Otherwise stick around. Okay, let's say you want to make your own sim and you followed 3 Dashes tutorial. Or downloaded the project file from Derivatives forum. Link in the doobly-doo. I will show you how to set it up to work with the rest of this tutorial. It will look something like this. This is the TOX from the forum. First things first, let's make sure the simres is square. This will just make it easier for us in the future. Also reset it to update the resolution. Second thing second, let's head over to the curl shader and just fix a little mistake. Oops, not the compute shader. Let's just change these to read from the Y component so we are actually getting the curl. Nice. Now we are going to want to find this velocity GLSL, where 3 Dashes adds the splats. We want to be able to input our own velocity inputs here. So, let's add an in top. And plug that in here. And outside we can drop down a noise top. Make sure it is the same resolution as our simres. (32-bit) float red and green. Monochrome off, offset 0. And plug that into the input. And back inside we can delete this velocity GLSL, and just use an add top instead. We can delete everything in this project that deals with color, we only need the velocity. We will deal with color outside the component. Nice, now let's set this up so it works similar to my component. Let's drop down a math top after the last null. And let's multiply this by the time step. That means multiplying this 1 divided by me.time.rate. Nice, we also want to turn this into sensible values. We do that by multiplying the red channel by 1 divided by the sim width. And the green channel by 1 divided by the sim height. We can do that in the range of the math top. And that way we have good values we can use to displace with. Let's hook this up to an out top. I'm calling this output pre-multiplied val. Let's create another output with other values we might want to use. I want to make an output with the velocities and the pressure in a visible range. We will use that for shading purposes in the next tutorial. Let's drop down a reorder and a select. And we want to monitor the pressure of the simulation, so let's grab the clear pressure null and store that in the blue channel. So in the reorder, output blue is set to input 2 red. And let's make sure this top is 32-bit float red, green, blue, and alpha. Connect this to a mouth and multiply it by 1 divided by me.time.rate. Let's hook that up to an out top. And name that to visible vel. Okay, this component is going to throw some warnings, but that's fine for our purposes. Nice, now we have a component that works similar to the one I will be using. Okay, for the rest of the video, I will use my fluid solver. It is available on my Patreon. But everything will still work if you've set it up the same way. I have a few other sliders and bobs, and the exact values might be a little different, but the concepts are the same. And it works the same. First thing I'm going to want is a keyboard in Chop that rests my sim. So just hook that up to the reset parameter. The uppermost input expects a monochrome boundary map. The lower input expects a velocity field, with the red channel representing the X direction and green the Y, so let's use a noise. Monochrome off, offset 0, and set to 32-bit float red and green. And chuck that into the seconds input. In the first input, let's plug in a rectangle. This will describe our boundaries. White means this is an obstacle, and black means this is not an obstacle. So I'm going to shape this rectangle to be a black outline along the edges. Something like that. Nice. We now have 2 outputs we can use. Let's call this null pre-multiplied velocity. And this one visible vel. Okay, let's see how we can construct a 2D particle system that will show this fluid sim. First we need some points. Let's use the point generator from the palette. Let's make it a rectangle and translate it by 0.5 in the X and Y direction. We want this rectangle to sit between 0 and 1 in the x and y direction. This is important. And let's drop down a null after that. Okay, we are also going to want the size to be 0.5. And let's set the point count to 1080 squared. We can do that by using two multiplied signs like this, meaning to the power of 2. Let's hook this up to a feedback top and a null. And let's select our pre-multiplied velocities. Now, if we reorder these to the positions, and we want the positions in the second input, and set the resolution source to UV image. Then we can just add these to our feedback loop. And there we can see our fluid sim in action. Pretty, huh? And I'll just show you that this still works even if you aren't using my fluid sim. Adding the keyboard in to also reset this feedback loop. The problem, as always with particles and feedback loops, is that they keep disappearing. So we need a way to return them back home. If you are familiar with my previous tutorials, you might feel inclined to use the life component here. And that's a way you can do it. I'll show you an alternative way today. With just a few lines of GLSL, we can get the same behavior. So let's delete the remap and add top. And let's plug in a GLSL top. Let's put the velocity into the second input. And we can write this directly in here, no need for fancy code editors. We are playing fast and loose. Let's uncomment this line. And turn this into a vec2. Let's name it P for position. And we just want to grab the XY component from this texture, the red and green channel. Let's create another vec2 variable and call it vel. Let's read the texture from the second input, and we do that like this. Make sure that it is reading from index 1. And instead of reading from the UV coordinates, we are using P in the second argument. This remaps the texture to our current coordinates. And we are only reading the X and Y component of this texture, the red and green channel. Let's also create a variable called life. And it is a float. We are going to keep that in the first texture's alpha channel. We are going to keep and read that from the first input's alpha channel. And then at the bottom, we just add the velocity to the positions by saying P plus equals vel. And here I make a silly little mistake, so let's just wait for me to figure this out. Obviously, we are supposed to output the positions. So the vec4 we are outputting has the positions in the red and green channel. Nothing in the blue because this is a 2D system, and the life variable in the alpha channel. Okay, now it works the same way again. And let's set up a very basic life management. We can say that every frame life plus equals 0.01, and if life is greater than 1.0, then life is equal to 0.0, and position returns to initial positions. But we haven't told the computer what our initial positions are, so let's do that real quick. We need a vec2, and name it initial p, and that reads from the third input. And just red and green channel. And let's grab tease null from before the feedback and plug that into the third input. And let's name this null to init p just for clarity. Okay, now our particles are resetting, but not in a pretty way. So let's offset our starting life with a noise. So, after the point generator, let's drop down a noise. Let's set it to random. And 32-bit float mono. Under the output set it just to noise. And let's plug in a reorder. Under output alpha set it input to red. Now when we reset, we have points that are constantly resetting. Now we have a particle system that is working. But we can set this up so we have more control. We will need to uniform floats. One for delta time, let's name it u_delta time. And another name u_life_time. And let's also assign those in the GLSL top. So let's create the u_delta time. And u_lifetime here. In the delta time, set it to 1 divided by me.time.rate. And in the lifetime set it to the value in seconds you want your particles to live for. And then in the code, let's set this up, we can remove this dummy value. And plug in 1.0 divided by u_lifetime. And let's wrap this in parentheses because I don't trust the order of operations. And multiply that by the delta time. And now we can set up how long we want those particles to live for. I'm going to put this at this corner of the screen so you can see the whole code. Like this. Neat. Now let's render this as point sprites. That's an add SOP. Toggle add points. A convert and convert to particles per point. Into a geo camera. And a point sprite material. And a render top. Let's set the resolution of the render to a square format. And let's drop down a null called POS. Turn instancing on. And let's use the POS as translate operator, using the red and green channel. The camera is orthographic. Origin is bottom left. And the width is 1. Nice. Let's turn the alpha down a bit. I think that's enough work for one tutorial. Check in for part 2 where we will create other render and shading options. Cheers.